thank you very much for the invitation, and it's a pleasure for me to present part of my research. So I'm currently working on, I'm responsible for water quality in our institute, and I work as a hydrologist, but also as a research manager. And the work on plastics we started doing a couple of years ago, but because we are more interested in terrestrial or freshwater environments, so our so the scope of our work are rivers and lakes. So we started looking into plastics in rivers because they might be an important pathway for plastics entering the ocean. So yeah, plastics. So this picture is from 1955, and you can see that back then, there was a big excitement about plastics and also single-use plastics because it's so convenient. And of course, and we heard it at the beginning of that session, that plastics are fantastic and versatile material. It's light, it's cheap. And probably when you think about it, our lifestyle or large parts of our lifestyle wouldn't be possible with plastics, without plastics, of course. But on the other hand, and that can't be ignored, the mass production and let's say the end of life of plastic products, the plastic litter, has become an environmental problem. And when you look at the plastic production, you see that it's produced in enormous amounts. So production grew from like beginning of the 50s from roughly 2 million tons per year to 380 million tons per year in 2015. And you see the big dark blue bar at the bottom of the graph, that's packaging. And so single-use plastics made up a big fraction of the entire plastic production. And of course, they're single-use plastics. They have a short lifetime, so they turn over to waste immediately and have, among those plastics products, they have the highest potential to end up in the environment. That's why also the EU, in its plastic strategy, is trying to avoid some of those single-use plastics. And a little side note, the plastic production increased faster than the global GDP. So plastic manufacturers were very lucky and had a very high growth over the last couple of decades. Okay, let's look at the waste side of things. So what we currently know, and I have to admit that many things we know are just roughly estimates because there's, from a scientific perspective, there's so few monitoring data compared to other substances that it's very hard to draw really solid conclusions out of the data. But what we know is that roughly 80% of marine plastics originates from land-based sources. And in 2015, it has been estimated by Jambek et al. To be in total something between 4.7 and 12.7 million tons per year of plastics that enter the ocean. So this is the order of magnitude estimate that we have from the land to sea transfer. And then we said, okay, because in the paper of Jambek, they didn't provide much information on the mechanisms behind it. And we know from our river studies that rivers are major connectors of land-based sources to the ocean. So they transport large amounts of sediments to the ocean. They transport nutrients. They transport particulate organic material. And so it was very close to say, okay, they also transport a lot of plastics. And the map on the left, this is the basin of the Mississippi River, and you see it discharges into the Gulf of Mexico. But you also see there's this dendritic river network, and you see that it connects even up to Canada. So everything that enters the river somewhere within the river basin of the Mississippi has the potential to enter the Gulf of Mexico. And this, for example, is a problem like for eutrophication of nutrients. So you may know that Gulf of Mexico has received excess nutrients from the Mississippi, and they originate from the Midwestern United States, where the big farms are, like Kansas and Oklahoma, for example. And those nutrients are transported over relatively long distances. Okay, so if rivers are a pathway for plastic, so what are potential sources? And one source, and this is the source that we specifically looked at, is so-called mismanaged plastic waste. And of course, there are also losses during handling and manufacturing. But of course, the plastic manufacturers, they are well aware of it, and there's also the clean sweep. I guess there's even a presentation of it later. So there's the clean sweep initiative. So something is done there. And then something we haven't looked at yet, and we think it's also important, I call it hydrologic events. So if there's a flooding of, I don't know, cities or settlements, there's a high potential of plastic in use that it's mobilized. And it's not necessarily waste. So it's just, material that is flushed into the river during such catastrophic events. And this is something we do not have any real good estimate of how much it could be beyond waste. So in our study, we looked just at the mismanaged waste. And how can you think of mismanaged waste? So I put two Google Street View images. The one is Dhaka. The one on the top is Dhaka in Bangladesh, and you can see what it means to have mismanaged waste on your street. You can see the waste lying there, and of course, there's a river next to it. And if there's a heavy rainfall, there's a high potential of material getting washed into the river. And below, I just picked randomly some small river in the metropolitan area of Athens, and you see there's virtually no waste. So that's a major difference. So in countries like Bangladesh and other countries where sufficient waste management, there's a higher potential of waste getting mobilized, getting washed into the rivers, and from the rivers into the sea. And what we did in our analysis, we looked at available data on plastics and rivers, and we collected the data in 2016, 2017, and there was not much. And what we found is, and this is hopefully the only scatter plot I show you, on the x-axis, this is the mismanaged plastic waste in tons occurring in a river catchment. And you see for microplastics, so we just categorized it into microplastics and macroplastics. I know it's not entirely correct, but we had to divide it somewhere, and so the division was 5 millimeter. And the x-axis is the amount of plastic waste that you have available for transport, like think of that picture in Bangladesh. And the other one are observed loads. And what you can see, the more plastic waste you have in your catchment, the more load you observe in your river. And but here there's no distinguishing between small and large rivers. It's just all the rivers that we had. And you see, because it's a log-log plot, if there's a slope above 1, that's or different from 1, it's non-linear, and a slope of 2 would mean it's quadratic. So it's almost quadratic, which means that larger rivers, larger catchments export way more plastics. And the one on the top for the microplastics on the top right in our study was the Yangtze River. And the Yangtze is a really huge river, and in the catchment of the Yangtze, there are 500 million people. So in the catchment area of the Yangtze, they're living about the same amount of people than in the entire EU. And the same relationship, or a similar relationship, also holds for macroplastics. So the general trend that large rivers export more plastic holds across rivers. Little fun fact, just to corroborate our findings, that there's not much data out there. In Germany, for nitrate, so which is important for eutrophication, there are 5,000 stations that measure nitrate. And for 2,000 of those stations, there are time series available that are longer than 10 years. And for the entire globe, in 2017, we had 68 measurements in rivers for microplastics and 35 for macroplastics. So there's a huge need for monitoring, and not only from a scientific perspective to make our results more solid and to reduce the uncertainty. It's also important, and this is also my call to the politicians here, whenever you implement some measures, of course you want to see if those measures are successful. So it's a good idea to implement some regular monitoring to see if something changes. I mean, if we measure in 10 years the same amounts that coming down the river than today, then we might see that our measures were not pretty effective on the short run. So there's need for data, and yeah, this is my call for it here. Okay, so what is the total amount that we came up? So we estimated, and also other studies meanwhile estimated, that rivers transport roughly 2 million tons per year of plastics into the ocean. So that's a global picture. And so there, you can see there's quite a big gap to the estimates of Jambeck et al. So the question is it just uncertainty, or are there other mechanisms that could transport that much plastic from land to sea? I mean, there could be wind drift from coastal areas, and there could be other mechanisms. I don't want to go into that here. So, but this 2 million tons per year, they seem to be confirmed also by other studies. So that's roughly that's the amount that rivers transport into the oceans. And in our study, we found that 90% of the riverine plastic transport originates from 10 rivers. There's another study that has less extreme values. That's why I'm a bit careful to state this 10 to 90 relationship as a solid result. It's subject to large uncertainty, and it's probably that also the other numbers, they are quite skewed, because if 2/3 of all, or they said that 20 rivers transport 2/3, and they also found that it's mainly larger rivers that transport the plastics. And there are different reasons for it. One reason could be that larger rivers simply are more efficient in transporting particulate material. We can also see it from sediments. But there's also that large settlements are predominantly at rivers and also predominantly at large rivers. So very large cities are often located at large rivers. So that might be one of the reasons the large rivers are those focal points of riverine inputs. And then something which I find also important, usually in the media and also in the scientific literature, there is a heavy bias towards microplastics. So many people discuss microplastics also in the ocean. And the reason for that is, of course, it can be enriched in the food chain. It can be ingested by aquatic life. So there's a higher ecotoxicological risk. And also from the left graph, it's particle concentration. Also, when you just count particles, there's of course more microplastics, and that's normal for particulate matter. Usually you have more smaller particles than larger particles, but when you look at the mass, I mean, there's also large scatter, but just look at the blue and the red bar. Mass-wise, they are approximately equal. So from a mass perspective, also the larger items, they are as important as the microplastics. And I would like to advocate this here a little bit, that when you do monitoring and when you look at plastics, you should always consider both fractions. Yeah, and that's my takeaway. So what we found, and which also confirmed by other studies, so rivers are at least a major pathway, if not the major pathway, from land to sea plastics. And of course, what can be done quite simply, when you look at this picture in Bangladesh, of course, in countries like Bangladesh, like in these developing countries, you have to get the waste off the streets. And the solutions there, that might not be the same solutions as we have, because we start from a different level. We can think about like improving a product life cycle. You all mentioned it, and it's all, circular economy. We're working towards the circular economy. We can design our product also for the end of life. We can implement deposit systems for food containers and bottles and everything, but this will not work in Bangladesh, at least not right now. So from a global perspective, the solutions must be tied to the local conditions, of course. And one thing is what we find, and that's also EU plastic strategy goes towards it, single-use plastic items are the ones that are predominantly found. And there's one takeaway which is relevant for Germany and I guess for entire EU, so also for Greece. What we see is a lot of plastic waste in sewage, in raw sewage. You can see it on the left. There are those those cotton buds, cigarette butts, and so that's also my informal takeaway for today is like, throw any waste into your toilet. So it should go to the waste bin, to the recycling system, to the waste system. It should not go into the sewage system, because this is what we predominantly find in our rivers is plastic waste, or waste in general. It comes from sewage. So that's my point for the Europeans. The toilet is not a litter bin. Yeah, thank you very much for your attention. And yeah, that's it from my side. Thank you.